Good evening, all. I welcome you all to the week 6 live session of Characterization of Construction Materials NPTEL course. I've already shared my screen. Is my screen visible?
Yes, ma'am.
Am I audible to all?
Yes.
Okay, thank you. So let's start the live session for this week. So, mm, so I think so. It's a week 6 live session. We are dealing with the week 7 content since you're submitting your assignments early. So I'm Nilakanmani. I'm a PhD scholar doing my research at IIT Madras. Uh, the course coordinator, Dr. Piyush Chonsali and Professor Manusantana are my guides, and we'll be having live session on 3 days per week. So on Monday, Tuesday, and Friday. So today's Monday's live session. So this week we'll be dealing with the questions from optical microscopy. Okay. So before going to the live session, let me show a small demo how to uh, give your answers during the live session. Okay, so I have posted some of the questions in the polls. Okay, to the bottom right corner of your screen, if you click here, you can find activities. And if you're using your mobile phone, there is a three dots. If you click that, you can find activities option. Out of that, you have to choose polls. Then you can see the questions launched. You can give your answer only when we discuss the question in the class. Okay, and then if it's a match the following question, or if it's a numerical problem, or if it's uh, a multiple choice question, more than one correct option is there, then you can give your answer in the chat box. Okay, so now getting back to the PPT. So I hope you guys have already watched the video, and coming Wednesday is the last day to submit the assignment questions from optical microscopy part. Okay, so here's the question one. So it's going to be to your first question. This question is launched in polls. Please give your answer in polls. Okay, so the question is, concrete samples are subjected to epoxy impregnation before imaging, before either it's optical microscopy or scanning electron microscopy imaging, since it helps with better imaging of dense materials. So here they're saying that first statement is concrete samples are subjected to epoxy impregnation. That is done. That is a statement. Okay. In that, they're asking what is the reason for epoxy impregnation. I've already started the timer. Here is the reasoning given is it helps with better imaging of denser materials. Is it really the reason for epoxy impregnation of concrete samples? Please give your answer in polls. If not possible, at least give your answer in chat box. This question, like this topic is particularly discussed in the lecture PPT in the first few slides itself. So I wish everyone knows the answer. Time is up. Let's see the class response. Okay, some of them given true, some of them given false. Okay. Here the question is not about the either epoxy impregnation is done or not. The question is why. Why epoxy impregnation is done. Okay. Let's see the correct answer. So here we could see preparation of this particular picture is from this snap is from the lecture PPT. Preparation of polished specimens of porous building material. So epoxy impregnation is done since concrete is a porous material, not because it's a denser material. Okay. See, if you polish porous material, what we can expect? What can happen if it's a brittle porous material? What we can expect if you do polishing? Can someone tell me? Consider a pumice, like we use it. Pumice is a volcanic rock, right? Porous rock. If you take and polish it, what you can expect out of it? it will broke, right? It will come into pieces and chunks. So we can't polish such porous samples. So in that case, we need to impregnate epoxy, and then it will intrude into the pores from the surface. Then if we polish further, the structure will not be uh, further deteriorate. Okay, so that is the reason. If you're willing to tell me the answer, you can unmute and tell me the answer, or you can post it in the chat box. I will read it later. Okay. So in that case, the reason for doing that is not it's a denser material because it's a porous material. Okay, no? So now let's move to the next question. If you have any difficulty in following the class, you can stop me by any point of time, or you can type in the chat box. I will check once I check the answers for the following question. Okay. So the question 2 is the match the following question. You have to give the answer in the chat box. You have to match the electromagnetic radiation with the order of their wavelengths here. Okay. So let me start the timer for 2 minutes. So here some of the types of radiations are given here: gamma ray, microwaves, radio waves, and the infrared wave. So in this case, you have to match the wavelength range with the wavelength scale. So if you what is the size of the gamma rays? How we can match which of the following object given can be matched with that type of radiation? That is the question. Okay. So we'll see the solution after 2 minutes. Please give your answer in the chat box. If you Google also, you can find the answer. It's very, very simple. If you know the wavelength range, it's very, very easy to match. Okay, still here 30 more seconds. I request everyone to give the answer. Time is up. Let's see the class response. Okay, there is options to do. Okay, okay. So you have to type the answer here. Structure, fracture. Okay. Fracture we can't say. We could say it's a porous material. So if you do polishing, there will be abrasion, the friction in between the sample and the polishing tool. So it crumbles. Okay. So you can't say it's a structure fracture. So if it's a multiple choice question, sorry, multiple choice question, it will be launched in polls, and or else you have to type the answer here. Okay. Sorry, I didn't see the chat box under there. Okay, fine. Let's discuss the answer then here now. So here is the magnetic spectrum. So now you can unmute and tell me. So let's consider gamma rays. What is the wavelength range for gamma rays here? Is it more than nanometer or is less than nanometer? Nice. Okay, it's even smaller than nanometer range. Okay, so it's a range of 10 to the power of minus 11 to 10 to the power of minus 13. It's less than 10 to the power of minus 11. So in that case, which of the following can match? Butterfly needle point, atomic nucleus, and tall building. So out of this, atomic nucleus will match here. Okay, so let me take a pen and point it here. Okay, so gamma rays we can match it to atomic nucleus. So in the other case, next one is microwave. So here microwave we can see the 10 to the power of minus 1 till 10 to the power of minus 3. It is less than a meter. It's less than uh, we could say it's from 1 millimeter to uh, 10 centimeter in that scale. So in that case, we can match microwave to, will it be needle point? No, right? So it can be in the range of butterfly, right? So next, if you see radio waves is about, it's more than a meter. So in that case, we can directly match radio waves to tall buildings. In other case, see, since I posed a question here, it's a well written answer in the chat box. So it's I just put it here to easily navigate you to where to give your answers. And when it comes to infrared, we can see it's in the range of 10 to the power of it's less than a millimeter, but it's more than a micrometer. So in that case, we can match directly to the needle point. Okay, right? So the correct answer is A3, B1, and C4 and D2. Okay. So now let's move to the next question. So this question is very simple question, and it is also explained in the first few lecture slides. Okay. So which of the following preparation procedures are typically required for imaging metal specimen in reflected mode? So here we are talking about the reflected mode. So there are different types of mode in optical microscopy. So that is also one of the question here. So the question here is which of the specimen preparation procedure are typically required for imaging meta specimen. So before we talked about how we can prepare sample for STEM imaging, right? We do epoxy impregnation for, let me start the timer now. So please give your answer. We are talk about epoxy impregnation, what we do. So we do epoxy impregnation for concrete samples. Since it's porous, we do that. So in this case, which are the following specimen preparation procedure will be followed for imaging metal specimens? Chemical etching or epoxy impregnation, carbon sputtering or milling. So the time's up. Please see the class response. Only two of you have given the answer, and the answer is correct. It's chemical etching. Okay, let me end the poll here. Is it really difficult for giving the answer? If you have any difficulty, please open up. So let's see the solution. All these questions are directly from the lecture PPT. So if you follow the lecture PPT, you'll be able to give the answers. Okay. So here, consider to be a metal specimen. So this much distance is equivalent to 100 micrometer. And after doing etching, chemical etching, so it's an aqueous solution of ferric chloride with uh, hydrochloric acid. So in that case, so what happens? A particular phase can be removed with etching, so that there is some uh, so there will be different topography as compared to the unetched sample. So in that case, the reflection from each of these phases after etching will be different. So in this case, we could see, so here most of the there is not much if it's the same phase, in that case we could see there is not much difference. But if you see different phases are there because after etching, so we could see there will be different grain boundaries. So in that case, we could see difference in the reflected beams, right? So in this case, the answer is chemical etching. So now let's move to next question. Question number 4. You have to choose the modes of operation in optical microscopy. It's a very simple question. So I'm putting a timer for 30 seconds. Okay. So you have to choose what are the different modes available in optical microscopy. Either it's reflected mode or transmitted mode, reflected and transmitted mode, or combination of reflected and transmitted modes. This question is given in polls. Let me stop the timer. Time is up. Let's see what is the class response. Okay. Reflected and transmitted, combination of reflected and transmitted. Okay. Let's see what is the right answer. So here in this case, I have not put any snaps from the lecture PPT. So see, when it comes to optical microscopy, we have two modes. One is reflected light mode and then transmitted light mode. So in reflected mode, to simply say, I'm not here drawing the exact path of light and all. So in reflected mode, here there will be a specimen. In that case, it will go based on the reflectance, it will give you some data. So when it comes to transmitted mode, it will pass through the sample and some of the light for some of the wavelength portion will be absorbed by the phases present here and remaining will come off. Here it is based on the reflectance and here is based on the absorption. So in that case, we have reflected mode and transmitted mode. Both can't be operated at the same time. So there is nothing called combination of reflected and transmitted mode. Okay, no? So now the correct answer is option C, reflected and transmitted light. So now let's move to question number 5. It's a multiple select question, so you can't give the answer in polls. You have to type the answer in chat box. Which of the following options are right one? You have to type it in the chat box. You may not type the full answer. You can just type if you find option A and B, then you can type as A and B is the right answer. Okay. So let me read out the question. Uh, Resolving power of a microscope is a function of. Resolving power of a optical microscope is a function of what of the following parameters? Let me start the timer now. After a minute, we'll see the solution. Here there are different parameters from option A to option E. A wavelength of light, numerical aperture, refractive index, magnifying power of the eyepiece, and magnifying power of the objective piece. So which of the following parameters or function of resolving power of optical microscope? You need to type. Please type your answer in the chat box. Time is up. Let's see the class response. It has more than one answer. That's why we have kept as multiple select question. Option A, B, and C. Okay, let's see what is the right answer. So here are the factors given, factors affecting the resolution. Resolution improves with smaller wavelength and then higher refractive index. Sorry, higher numerical aperture of the lens system. So in that case, the correct answer will be wavelength of the light used and numerical aperture of the lens system. Okay, so um, here they have But some of you have given A, B, and C, I guess. So the correct answer is option A and option B. So now let's move to question 6. It's a true or false question, and it's going to be very, very simple question. If you know what are the lights, just now we discussed about the uh, how wavelength affects resolution. Okay, we need smaller wavelength for better resolution. Here the question is about blue light and violet light. Okay, blue light has better resolution in optical microscopy than violet light. Is that so? Let me start the timer for a minute. Sorry. So, so here they're talking about blue light has better resolution than violet light. Think about in the wavelength range. Is blue light wavelength is smaller than the violet light? You have to think in that way and give the answer. Please type your answer in the. Please choose the answer from the polls. I've already launched the question in the polls. Time is up. Let's see the class response. Okay, you found it's true and it's false. Okay, yeah. Even though it's good that you brought it to the discussion. I was about to discuss the same thing. Actually, it should be transmitted. Okay, sorry, I didn't read the chat box for a long time. Uh, Actually, it should be transmitted or reflected lights. It's so the different modes in optical microscopy is reflection mode and then transmission mode. Okay, what I discussed. Even though violet light is smaller, we prefer blue light. Yeah, we prefer blue light, but when it comes to resolution, we talk only in the terms of wavelength and the numerical aperture, right? As per the last question. So in that case, if we see factors affecting resolution, we know that we have to look for the wavelength as well as the numerical aperture. I think for the last question, even refractive index will also be the right answer, I feel. Since it's not so clear, since the option is not so clear, I think refractive index of what? Since it's not given, I think they are not. It's not given as the right answer. So in that case, even refractive index would also be the right answer, right? Sorry, I didn't include it as the right answer. Sorry. So now, but the major factors we say that we have to improve the we have to reduce the wavelength and also we have to increase the numerical aperture of the lens system. But we never talk in the terms of separately as a refractive index, since numerical aperture itself includes refractive index. That could be the reason. If you say refractive index or numerical aperture, you have to choose one, then you will choose numerical aperture, right? So that could be the reason. Okay. So now here we know that the wavelength of violet light is even smaller than the blue light, right? Blue is 475 nanometer and violet is 400 nanometer. So in that case, blue light has a higher wavelength, right? So how we can say that blue light has better resolution? So in that case, we can't say that, right? And why we prefer to use blue light is eyes are more sensitive to blue light than violet light. That is the reason why we go for blue light. So blue light has better resolution optical microscopy than violet, which cannot be the correct statement. It's about the comfort level. So eyes are more sensitive. Since eyes are more sensitive, we prefer to use blue light. That doesn't mean that blue light has better resolution. Okay. So I want to emphasize this point. That's why I put this question. So now let's move to question number 7. Uh, it's again a true or false question. Let me start the timer now. Please give your answer in the chat. Sorry, it's not chat box, it's polls. I think everyone could have seen the answer. It's fine. Okay, so give your answer in polls. The question is, in case of a dual lens system, the IP is an objective or fixed at a finite distance. Is that so? So as discussed from a single lens to dual lens to single lens and compound lens also he discussed in that. The first case he discussed would be dual lens system. Then he moved to multiple lens system, compound lens system. So in that case, is the IP is an objective of fixer at a finite distance. Okay, since time is up, let's see the class response. Okay, yeah, the correct answer is true. Let's see the solution. Sorry. So in that case, you could see here the given system is a dual lens system. There is an objective lens and eyepiece lens. So in that case, we could see if it's a if a single lens system, in that case, the range of focal length can be varied since there is no fixed position. And eye also has an adjustable focus. So in that case, it will not be fixed. But if it comes to a dual lens system, it's not so flexible. We need a specific distance, and to capture photo or a videograph of the image, it should be a fixed distance, and it should not be a varying distance. So in that case, type is an objective of fixed at a finite distance. Okay, so the correct answer is true. Now let's move to the next question. The question number 8 is also very very simple question. So short. Let's give the right answer in 30 seconds. If we put a timer for 30 seconds. Okay, here is the question. Anisotropic material exhibit birefringence. This topic is particularly discussed in the polarized light microscope. So they use isotropic material as well as anisotropic material. Sorry, in the lecture PPT, they have discussed about isotropic material as well as anisotropic material. Which case gave birefringence? You have to think about and then you have to answer. Okay, please give your answer in polls. Time is up. Let's see the class response. Okay, both true as well as false. Okay, is there anything from chat? Okay. So, okay, this is the last question now from polls also. Okay, so you guys think it's false now? Okay, fine. Let's see the class response. Here, this particular diagram is from the lecture PPT. The snap is from the lecture PPT. So, in polarized light microscope, they use an polarizer, right? If it's an isotropic material, it doesn't resolve the beam. There is no effect. There is no effect of polarized light. So, in that case, it will be same. Uh, uh, so same beam will be passed through the after after being passed through the polarizer. There will be no difference. See, right? It's in a particular direction, and after passing the polarizer also it's in the same direction. Okay, so in another case, if it comes from polarizer, So here, if it's an anisotropic crystal, in that case, it resolves the polarized beam into two perpendicular directions. So in that case, there will be bifringens of the beam passed from polarizer. So in that case, a particular beam is removed from analyzer, so still there will be one component. So in that case, anisotropic material is helpful for polarized light microscope. So anisotropic material exhibits bifringens. That is the point. So the correct answer is true and not false. Okay. I hope you guys got it right. So now let's go to question number 9. Question number 9. Hereafter there is no answer, no question launched in post. You have to give the answer in the chat box. So the question is, which of the following relations between intensity, magnification, numerical aperture are correct? For this case, you should know what is intensity. Intensity is nothing but the intensity of the light beam. And magnification, once you use zoom option, it's nothing but magnification and numerical aperture. So we have to relate intensity, magnification, numerical aperture and find the correct statements. Let me start the timer now and please give the right answer. Option A is intensity of light collected increases the square of magnification. Option B is intensity collected decreases the square of magnification. Option C is intensity increases linearly with numerical aperture and intensity increases as the square of numerical aperture. Please type the answer in chat box, and this particular question has more than one right answer. Let's see the class response. Okay, B and D. Thank you. Thank you, both of you. So now let's see the correct answer. So here in this case, the correct answer is both option A and option B and option D. So here is the snap is particularly from the Raksha PPT. So the intensity of light collected decreases the square of magnification. See, once you go to magnification, you just zoom and get inside. So in that case, the amount of light collected, you are neglecting some portion. So in that case, it decreases the square of magnification. You got it right? So in that case, so if you take a particular, okay. So if this is the image and if you're trying to magnify this particular portion here shaded, so in that case, you're magnifying this portion again and bringing it to this way, right? So again, this will be magnified to that size, same size, but the image here will be this much. So the intensity of light collected will be the same, but it's zoomed further. So in that case, the intensity of light collected decreases the square of magnification. So in another case, intensity increases the square of numerical aperture because the light collecting capacity is further increased when we increase the numerical aperture. So intensity increases when we increase the numerical aperture also. So then uh, and if you have to have a better uh, quality of image, then there should be low magnification and high numerical aperture is desired for better imaging. So in this case, most of you given the right answer. Now we'll do some problem. I know the same problem is discussed in last class. I have no idea. Is the same problem discussed in the last class? If the same question is discussed, then we can change the wavelength number. That's why I'm asking. Okay, then let's see the.
Yes, ma'am. Same problem.
Okay, then I'll change the wavelength. Just a minute. No, wavelength it will be difficult now. 650, 470. So now you can solve the problem. Sorry, let me do this time. So this is the question. So now let's do the problem. So here, before it was, since the question was discussed in the last class, I've changed the wavelength number here. So now we can do the problem. You have to calculate the resolution that can be attained by using yellow light in air and then from blue light using water, in water. And here the values are given, and I'm helping you with the formula also. Resolution can be calculated. D is equal to 1.22 uh, wavelength divided by 2 into numerical aperture, and numerical aperture is nothing but refractive index multiplied by sine alpha. Then it's already given here, it's 0.95. Okay, so can you guys uh, calculate and tell me the answer for A option, for 10A? And you can, if you have calculated, you can post it in the chat box, and if someone is willing to unmute and tell me the answer, please tell me the answer. And since the numbers are changed, let me also calculate it and get the answers right. Yeah, we'll do the problem, and let me start the timer for 2 minutes. So after 2 minutes, we'll discuss the solution. Okay. Since here the values given is in, sorry, so here the value is given as a nanometer, and you want the answers also in nanometer, so you need not change the values of the wavelength here. Okay. I'm done with the calculation. Still only 10 seconds more. So here the wavelength is already given, wavelength, that's nothing but lambda. And the numerical aperture you have to calculate it as n multiplied by sine alpha, and sine alpha is already given. Refractive index n is already given here for air and water. So in the first part you have to calculate, use yellow light and air, refractive index from air to calculate the resolution. And in case B you have to calculate, use blue light, and then with water, refractive index from water as a medium. So in that case, it's very, very simple. Let's see the answer from the chat box. Okay. 265. I didn't get the 265. Okay. 385 is okay. 26.06 was right. 234.615 or 62 is right. Okay, fine. I could see answer particularly from this Pratiksha Patil and then Smita Bhavat, Prasad Bishop. Okay, I could not see any answer from other people. Are you guys still in the class? Okay, fine. Today's class is over by now. This is the last question for this class. Thank you so much. If you guys have any more query, we can discuss or else we can discuss the class. Let me type also the right answer. Option A is 385. I'm correcting it to two decimals after calculating, typing it only up to two decimals. And then option B, 234.62 we can say. This is the right answer. You guys have any more query? Let me stop sharing now. You guys have any more query? Okay. Thank you for being so patient in my class today. Mena, I could not hear any voice from you. Are you still in class?
Yes, ma'am. Today I am not well.
Okay, fine. Okay, Mena, take care. Okay, then we'll meet next Monday then. I hope you guys watch the video and go for tomorrow's live session, and you guys get more questions from tomorrow's live session. Yeah. Okay. Yeah.
Excuse me,
Yeah.
ma'am. Actually, I just wanted to know, well, calculating the velocity of the light.
Okay.
So there should be C by N formula you are going to use.
Yeah. Yeah. From the Lakshmi Pit is given. Yes. Yeah.
Yeah. So N means that will be with respect to air. We need to calculate it or what? Refractive index.
Whichever medium is there, we have to consider the refractive index. Either it's air or water, whichever medium is there. See, see when it comes through air, the velocity will not change, right? So if it's a different medium, then you have to consider the refractive index of the particular medium.
Okay, fine. Thank you.
Yeah. Okay. Then we'll stop this live session now. Thank you for being so patient. We'll meet next week. Thank you so much.